Hello and welcome. In this video, I'm going to be solving some coding competition problems using GitHub Copilot. To give you a bit of context, today is the first day of my holidays, usually when I start making some YouTube videos, given that I teach for most of the year. And one of my students showed me how I can get GitHub Copilot for free. And I did. And I decided to toy around with it and try to solve some problems from the 𝗦𝗘𝗖𝗓𝗡𝗗𝗏 Coding Challenge, which is a statewide coding competition that I'm organizing. Now, these problems are really for kids in year 7 to 10 that are very, very advanced for their age. And I mean, realistically, they'd be probably appropriate for maybe first-year university students. And I've tried 3 of them using GitHub Copilot. And the question is, how did Copilot do? Well, you're going to see yourself. The short answer is, I think it went great. I solved them much faster with Copilot than I would without it. And for one in particular that required, a bit of specialist knowledge, basically how to open zip files, how to enter passwords into zip files, that only took 2 or 3 minutes. Whereas I remember when I first solved it, that was like 25 minutes on Stack Overflow, and most of the sample code didn't work. So yeah, watch, you're going to be blown away. All right, so let's get into it. In the first problem that I want to look at, we're going to call this identical twins. We've got 2 books, Wizard of Oz 1, Wizard of Oz 2. And this is what the problem says. You have in hand identical 2 copies of Wizard of Oz. Here they are. They are 99.99% identical, yet the differences between them yield the flag. So this problem here involves reading 2 text files, comparing them character by character, and printing out the differences. And obviously the differences, they're going to have some subset each of characters that are different from the other. And one of those, or a combination of them, is going to be the flag. So how can we use Copilot to solve that? Let's have a go. So the way that I see it, with Copilot, you really want to use a function. So a function, or something like this function, compares 2 strings and returns the difference. So def compare A, B. If A equals B, return 0. Returns the, let's try different characters. Let's try that. Okay, compare strings, string 1, string 2, and returns the different characters. So initialize the list of differences. This looks interesting. So differences is that for I in range, length of string 1. If string 1 doesn't differences dot append string 1i. So this could be string 1i, it could be string 2i, return differences. This is great. Okay. So now I can test function. If I say test the function, print compare strings, hello and hello. Actually, this is great. What's wrong with this? It's giving me Python 2, not Python 3 on the print statement, which is weird. But let's run it. And the difference is E, which is, yeah, pretty good. Why don't we try to open the 2 books? Open, wizard. How come it's not autofilling? Okay, Wizard of Oz 1.txt. Dot read. So we'll take the first one and the second one and run it. Compare strings. So I need to close the print as well. lots of brackets. Char map some codec thing. So what if I said, I think it says encoding equals to UTF 8. Or is it UTF-8? All right. I'm about 90% sure it's gonna work. There it is. That is the difference if we print string 1, but if we did string 2, that would be the flag, with forever. And let's see, return the list of differences as, if I said as a string, and then, ha! No, that was good. Tab. There it is. That's the flag. I reckon this is one of those where probably the Copilot saved me a bit of time. But let's keep going. Let's try to solve another one. So next we're going to have an example called coordinate art. And it says the following. We've intercepted 2 coordinate lists. We believe one of them will spell out a 4-character flag. So the idea is that, you know, these are, I'll show you what they look like. These are lists of split integers. And if plotted, they're going to show some secret message. So let's take a look and see what we can do. I'm going to create a brand new Python file. And I'm going to say chords.py. Okay. So let's start with something like this. Function. Reads a list of coordinates from text file and plots them on a graph. Okay, graph, 2D graph, that plot chords, great. Open the file, chords.txt, great. Now, why don't I call this my file or whatever, chord list, and then that could be chord list. It will read it. We've got X and Y here for line and file, line split, X is that, plt.plot. Okay, so we need to do import plt, and I'm not sure which, okay, there you go. I think the fact that this is underlined is worrying. Could not be resolved from source. Pip install. This new VS Code looks so good. Anyway, we even imported a library. Like, I'm not that fluent with matplotlib and pandas, haven't used them for years. So it looks like this is going to do it, potentially. Okay. The import looks correct. I'm pretty nervous here. So let's test the function. Test the function. Plot chords. I'm really not sure why it's not intercept 1. Can't you read what I've got in my folder? Oops. Man, this is going to be interesting. Int line 0. 49, 0. Okay. It says line equals line dot split. And what if we split the thing on a comma? Like, would this solve our problems? Wow. Okay. This is it. It's a galloping horse, I know from experience. So the idea is, if instead of actually dotting the dots, if they left a stamp or something, right? So line equals dot split, plt dot plot. So what type of graph? Like, is there a stamp? Plot the points. Do not join them. Like something. Oh, interesting. What is this? Oh. Yes. Look at that. That's that galloping horse. As you can see, the horse is upside down. It's kind of like interesting. If you stretch it a little bit, you can kind of see this. So if we perhaps reverse the y, x comma negative y. This is interesting. Y dot append int I see. Line dot split int. What if I made y just a negative? Look at that. That's a running horse. And if we just turn this to intercept 2. Okay, maybe a little bit of a squash. 6, 7, 3, 1. Wow, actually, I'm pretty impressed. So there you go, Copilot to the rescue. Like, my impression of the Copilot is you really have to know what you're doing. You have to be very familiar with the algorithm you want to implement. You have to troubleshoot as you go along. But it kind of, it found the right library for me. It found the right function. Like, when I said do not join them, like, that is just unbelievable. It's really, like, Copilot is the right term for it. Okay, what are we gonna do next? Okay, so the next one, I'm gonna try to do the next one even without this list of possible passwords, right? So the idea is you have this zip file and you need to open it with a 3-letter password. Now, there is 15,000 possible 3-letter passwords. If you take a look at this list of possible passwords, I really should have said in the competition lowercase 3-letter password, because, yep, about 15,000 lines down, it's easy. So how are we going to do that? How are you going to open that file with a password? Again, for a lot of the kids in the competition, they never would have opened any type of Office archive or any type of file using Python, let alone how to try to crack it. So let's see if I can basically coax the solution out of the Copilot here. Okay, here we are. The archive is here. We're going to create a script, zipcracker.py. Okay, so first thing, create a list of words. Should we say create a list containing every possible 3-letter combination? Words for I in range. This is interesting. 97 to 123. I mean, what are you going to do? ORDs here? What are you going to do here? Can we possibly come up with a list? What about if I say create the alphabet as a list? Surely. Can you do that? Of characters, yep. Ha! Beautiful. All right. So we got the alphabet. Create a list of every possible 3-letter of the, oh my god, it's gonna do it. ABC for a, oh yes, yes, print oh my god, it did it. And it did it as list comprehensions, and it's short. Wow. Okay. Now, open a zip file using a password. Okay. Okay. Oh my god. Zip extract all. Oh my god. So I need zip file. Surely. Do I just import zip file? Like, will that do it? Import zip file. Okay. What a start. Secure zip. Nice. It does this encoding. I mean, from experience, I know when you're trying to enter password into files, there's like, you got to encode it as bytes. It's really tough. If this works, I'll be blown away. So exception of the password incorrect, return true. So pw equals password.encode. Now, open zip file password. We have a password. So now, loop through the combinations. Oh yes, for combination in combinations. If password is correct. If open zip file combination, the password is, oh my god, if this works, I'm gonna be giddy. It worked. It unzipped the flag. There was flag and not flag, and that was the flag. Wow, it unzipped it, and it said the password is GTA. Okay, that's all for this test. Yeah, I've got to say, I was blown away. The last one in particular, I mean, this is not, the zip cracker was not an easy one. I mean, creating a list of all of the 3 combinations in the alphabet, not the most trivial task, done in this neat one line. And then, I mean, if you just go through the documentation of zip file, like, you will know actually entering the password is tough. That, like, you really need to worry about encoding, whether you're going to encode it as bytes, UTF-8. There's all kinds of things that work and don't work for all sorts of reasons. Just the fact that this worked for the first time was unbelievable. I remember when I did this problem myself after actually creating it, it took me half an hour. I think this took 5 minutes. I'm blown away. Okay, that's all for this one. I might make more adventures in Copilot, but make sure you like and subscribe, and I'll see you in the next video.